Okay, hey, good morning. Still in morning, right, everyone? First of all, thank you so much for putting this on. It's a really great event. It's my first time in Denver. First time being at altitude for any sort of length. It's a great experience. The beer works even better. But yeah, so for those of you who don't know me, I'm Phil. I work at a company called Mux. It's a small California startup. I want to talk about the evolution of video APIs. Now, it's may or may not fit super elegantly into kind of the players and metrics bit, but I think this is actually a really interesting subject, because I think it's somewhere that we as an industry haven't done an amazing job over the last few years, and I think we can kind of talk through why and how we can kind of make things better. So, a little bit about me. I work for Mux. I've been in the industry about 10 years now. I used to work at Brightcove. I worked at the BBC in London. I co-organize the DMux conference. By the way, we're hosting drinks tonight, same place as last night. Come along, talk about video, you know, the usual things. But I also organize the London Video Technology Meetup. I speak on a podcast about video. Apparently video is my life, but anyway. So we're going to talk a bit about video APIs, kind of some categorizations that we can come up with for video APIs. We're going to talk a bit about why having a great API actually matters these days, and if it matters at all, and some considerations we can take into account when we're building video APIs. But first, what makes me qualified to speak about this? Why do I get to speak about video APIs? So I've kind of spent the last 10 years in the industry, and a lot of that time has been building or consuming video APIs of different companies. So at the BBC, I interfaced with many vendors in this room's video APIs, and I built private APIs as well for internal consumers. Then I went and built a boatload of public APIs that probably some of you have consumed at Zencoder and Brightcove, and we now build kind of API-first video services at Mux. So I've done this quite a lot, and I've made a lot of mistakes, so I want to help people understand my mistakes. So what is a video API, though? What am I calling a video API? So to me, this is anything you use to programmatically manipulate video. Generally, I'm going to talk about kind of software as a service or, you know, platform as a service APIs, but I think they really break down into two categories. The first one is encoding APIs. I'll talk about that in a second. And the second one is video platform APIs. So encoding APIs. So I came up with this name. I think it's a terrible name. I don't think a pure encoding API, certainly as a SaaS, really exists at all. Generally, we're talking about things that are not only kind of encoders, they're transcoders, muxers, packagers, file transfer agents, DRM agents, all these sorts of things rolled up into one API. The commonality between these things is they give, you know, fine-grained control over the encoding settings. This is what their key sales feature is. Generally, when they're SaaS, they work with remote object stores, things like S3, Backblaze, GCS, all those sorts of things. Here are some of them. Many of these are in the room today. You know, Zencoder, one of the very early ones, MediaConvert, one of the more modern ones, and a lot of things in between there as well. So I've done this for a couple of bits of this presentation, is I've put together a bit of a timeline just to kind of give ourselves some context. So we've got about 10 years on this timeline, looking into the future as well, and we've kind of got the dominant technologies at the bottom of the timeline. I want to put kind of some releases and some feature releases onto this timeline. So Zencoder was one of the very early video encoding APIs. 2010, very simple XML JSON API. The XML API did disappear eventually. Really trivial, simplest job though. We also allocate you temporary output storage that I'll touch on in a minute, and kind of some SDK support. 2013, Elastic Transcoder comes out. I was actually on the beta for Elastic Transcoder at the time. AWS-style APIs. Interesting because the level of abstraction is different. Amazon decided to separate out the concepts of kind of your concurrency and your input and output storage from your actual kind of encoding settings, which is an interesting decision. Good SDK support. Amazon tend to be pretty good at this. Bitmoving guys are in the room. Originally Bitcoding, 2015, kind of a more complex JSON API with a large minimum payload to achieve anything. Good SDK support again, and kind of an active encouragement to use the SDKs over using HTTP APIs. 2017, bringing us kind of up really recent. MediaConvert, obviously kind of a derivative ultimately of the things that came out of Elemental, but in JSON this time. I integrated with the XML APIs at one point. Advanced broadcaster friendly, again, quite big JSON APIs, huge documents to do anything. And good SDK support again. Again, Amazon doing well there. So kind of how have these changed, how have these evolved? So the granularity of control has increased a lot. We can do a lot more with these APIs. But also the complexity of these interchange has kind of grown dramatically. And here's an example of that. So this is Zencoder v2 2013. This is the simplest job you can do. It's one JSON element. It'll actually go off and run a job. It'll download a file. It'll pick, I think it's 1 megabit H.264 MP4 output, and that's it. And it'll actually allocate you some output storage as well and give you a temporary URL back. It's actually a really simple way of doing something with video. Here is the exact same job using Media Convert. It's quite a lot more verbose, and a lot of these things could be set as sensible defaults. You don't need to set kind of hundreds of things to do a simple job. You know, we can kind of do better than this. But why is this happening? Well, I think there's less targeting of this kind of developer-centric market and more targeting of kind of people who are coming in for a systems integrator, a broadcaster, a media company sort of space. But I also think there's less upfront design going into APIs at the moment. I think that's something we can work on as a group. Then, I won't spend much time on this, but kind of video platform APIs. These are kind of the APIs you get from your OVPs, your Uyalas, your Katuras, your kind of video clouds. Because they're kind of closed ecosystems, you end up with multiple levels of abstraction in the APIs. You have things like a catalog API, an ingest API, a playback API. Yeah, these are the kind of big players in this market. JW Player, obviously a player, but also kind of the video platform as well. Your catalog APIs are the things we generally as a group don't care about, right? Titles, descriptions, metadata, not really interesting to us. Ingest APIs are. Ingest APIs generally tend to look a lot like these encoding APIs we talked about, right? A lot of OVPs, though, tend to abstract away the profiles underneath a different API, which actually makes a lot of sense from an abstraction standpoint. Then we've got playback APIs. So this is kind of, give me some URLs so I can play back my content. Generally, these might be tokenized, expiring URLs, these sorts of things. These are secured APIs, but often don't tend to be secured that well, and we'll talk about that a bit more in a minute. So again, we've got our little timeline coming up. Does anyone remember Longtail? There you go, a few people. Yeah, you work at JW Player, that's cheating. So launched kind of a video platform, XML-based API. Interesting sort of time with the two APIs, catalog and ingest were kind of associated together, and then playback was separate, which is cool. Good generated API documentation. This had kind of push and pull-based ingest as well. 2013, I want to highlight the launch of Uyala's Rights Locker product, a really interesting product if you're into playback security and authenticated playback. And we'll talk a little bit more about that in a minute. A couple of video cloud changes I wanted to highlight. Brightcove replaced all of their kind of cataloging APIs in 2015, and then in 2016 released kind of this push-based ingest, pull-based ingest approach, which superseded kind of old FTP, Aspera drop-off sort of endpoints. But what's super interesting there is in 2018, Brightcove then re-added a way to push ingest into these sorts of systems. So one of the big changes we've seen is this migration from kind of a push-based ingest to a pull-based ingest, and then push-based ingest kind of coming back again just as a different set of technologies, be that kind of a signed URL into S3 or Google Cloud Storage or stuff like that. And there's this emergence of playback security. Now, traditionally, these playback APIs tend to be kind of a weak point in the security model of OVPs, because this isn't about DRM necessarily. DRM is completely valueless if it's anonymous DRM. If you're not actually making any attempt to verify who's viewing the content and whether they have the rights to do that, your kind of authentication model is just valueless. You can go and buy a Kodi box on the market today. It has a Widevine stack in it. It has a PlayReady stack in it. If you can just go get new URLs, this isn't actually that valuable. Rights Locker was a good example. It was a kind of multi-faceted authentication technique where kind of the owner of the content got a say in whether it's allowed, and the OVP, and all these things kind of put together. It's kind of a shame to see Brightcove moving away from that, really. So why haven't they evolved more? We kind of saw a good, nice track of evolution for encoding APIs, but less so for these platform APIs. So OVP APIs tend to be pretty slow-moving, and this is mostly about fear of breaking customer integrations. Because they don't tend to be the most technical people you're integrating with, the API kinds of integrations end up being complex, outsourced maybe, and there's kind of this lack of desire to support multiple versions of the same API, but there's actually some good stuff you can do there that I'll talk about in a minute. I think there's a couple of other APIs that are super interesting to talk about. I think FFmpeg is a video API. This is something you programmatically use to manipulate video. I know I've built a ton of systems where you dig into it and, oh, hang on, we're executing an FFmpeg command under here. This is pretty common stuff. You know, we should probably all be using libav natively, but I don't really have time for that. And I think FFmpeg is interesting because it has some really cool default behavior and really interesting default behavior. It's a lot more mapped to kind of the Zencoder approach, right? These are two jobs that I can run on my laptop. Anyone know what kind of these would do as a generalization? A rough idea? Okay, so it's pretty much going to transcode it. It will always transcode because you're not kind of telling it to transmux here. On the bottom example, it will actually, on my laptop, picks VP9 and Opus. And on the top, it'll just kind of re-encode the MP4, dual progressive MP4. But it does things on this most default, simplest invocation, which is pretty important. We've kind of changed at Mux the way we think about video APIs as well. We kind of built more of a somewhere in between this encoding API and platform API, but specifically with avoiding this concept of having kind of catalogs and playback APIs. The way we look at it is we want to be super simple, kind of like the Zencoder ingest command, but then also we're allowing you to playback, right? So you kind of need to tell us if it's public or private if you want authentication on your playback. You get an ID back when you ingest stuff, and you can just throw that into a stream URL or a thumbnail or an animated GIF or associated other things. So it's kind of this interesting space of not quite an OVP, not quite an encoding platform, something different. But why does any of this matter? So SaaS is the new normal, right? Your customers want to be able to experiment with this product without writing hundreds or thousands of lines of code and integrating. And the developers are so empowered these days to maybe even make decisions about vendors, but certainly influence these decisions. If those developers have had a great experience experimenting and playing with your APIs, this makes a big difference to whether you win or not in that market. And if you are in a developer-centric market, this is just critical. Now, a lot of people might say, well, we're not in a developer market, we're in a media or in a broadcaster market, but there is, in the nicest way, a finite number of media companies. Yeah, they come and go, but slowly. Whereas there's this infinite cycle of really quick cycling startups who actually just want video experiences in their apps. Video may not be that core thing to the app, but it's part of the experience. There's opportunities here for everyone in the room to be friendly to people who just want to do things with video. You can empower kind of normal full-stack developers by having a great API. And I don't think we're great at this as a community, like I said. You know, we're from video engineering backgrounds, right? Not necessarily a SaaS background. We kind of get stuck in the weeds of the ideas of building a product for ourselves, not necessarily for generic developers. But there's also a certain blame to lay on kind of product here. We tend to think about kind of functionality and GUIs rather than kind of this experience through using the API. So here's some ideas. Here's some considerations we can make to hopefully make things a little bit better. So I think the most important thing is design, right? We have to upfront design these APIs going forward. And it should be part of the product process. It doesn't need to be engineering-led. It can be kind of a combination of product and engineering, but it should be part of your design process when you're putting forward products. But beyond this, it doesn't want to be a purely internal decision. This can be a two-way relationship with customers and prospects, understanding what they want and what they need. They're going to give you way better feedback than you'll ever give yourself on your API design, because they're actually the people who's going to use it, and you probably won't use it as much at all. There's a bunch of tooling you can use to do this. OpenAPI is a way of modeling APIs, RAML, API Blueprint. There's quite a few out there. These are kind of great tool prints to kind of lay out what you're designing, thinking about the entities you're talking about, and you can also do really cool things with this. You can generate SDKs, you can generate documentation, you can make kind of your release and maintenance cycles when you build an SDK way shorter and way more powerful. I strongly recommend investing in these. Abstraction is really important for those of you who care about the API elegance. You've got to think about it up front. You really have to. And again, kind of something that should be done with your product as well. Like, what's the problem you're trying to solve? Who's the target market? But one I like to ask myself is, like, what do the people who are going to use this API know about video? Do they know everything I know about video? Do they know everything you know about video? Or is it kind of a smaller, or do they know nothing about video? In which case, they are going to want a very different API to the people who know kind of everything about video, the same as you. Kind of having one level of abstractions pretty important. I'd encourage you to rearrange your APIs if you find yourself having odd levels of abstraction. It's something you should actively think about, though. And on that note, kind of revisiting your API design is really important. We have a tendency, everyone has a tendency, to kind of shoehorn things in when it's just, well, I can just pop this field in there, never mind if it really fits in that concept, but you should revisit this. When APIs grow, naturally they tend to mutate away from the original concepts that you were working with. So when you're thinking about new features in your products, you should think about your API design when you go to build this. Simplicity is really important. I've touched on this kind of 2 or 3 times, right? So default behavior should be simple and kind of what the user expects. It should help customers get started really easy. Here's some ideas, right? Kind of the Zencoder approach, MP4 in, MP4 out. Input file to HLS ABR like we do at Mux. Or like, it would be sensible to default to H.264. That's overwhelming majority of devices right now. Maybe follow the output file name like FFmpeg does when you run it. But beyond kind of the simplicity, there's then the ease of integration. This is more than just defaults, right? This is simple minimum API request success, trivial authentication, which probably means no OAuth. And the way I like to think about the integration simplicity is really about, if you can use an API when you're talking about HTTP, can you just use it using curl? If so, great, you've probably built a pretty easy to integrate simple API. If not, then maybe worth thinking again. And here's an example of that, right? Here's a 16-step guide to starting with OAuth. This is a pretty daunting thing if you're a kind of full-stack developer. Oh, great, now I have to go and integrate with OAuth. Oh, now I have to... I think actually this one includes writing a little Node.js app to do the transparent authentication for you. That's not a great experience. And, API tokens are a really great way to do auth that just kind of works. And there's a reason why the biggest startups and the biggest companies in the world are successfully using API tokens. People like Stripe, Twilio, SendGrid, all these sorts of things. But you want to document your APIs as well to help out customers in their first phase. Even if it is a super simple API request, your documentation should still be really strong. So customers won't use your APIs unless they're well documented. I really strongly recommend documenting in HTTP form. Some people don't do this. I think it provides customers a really easy ability to understand what's going on under the hood. Whereas if you kind of hide it under SDKs, that can be really tough for people getting an understanding of what's happening in your product. And again, you can do this programmatically. A lot of this stuff can be done programmatically. I wanted to actually have a vendor's error message here, but the terrible error message was fixed. Great error messages help users, right? This help people integrate. And validating early is really important, right? If you can reject something on the initial HTTP request rather than waiting to kind of go through a validation phase, poll it, and then give a rejection back, you should probably do that. Use sensible HTTP codes. There's a ton out there. You should just use the industry standards. And don't be Windows XP is really important. And critically, you're looking for this stickiness concept, and you're looking for just the right amount of stickiness. So you want your product to be sticky, not your APIs to be sticky. So if your API is great, your product kind of becomes this naturally sticky. But you don't want it to be too sticky, because you don't want people to feel locked into your product. And there's a few components to this, but versioning your APIs is pretty important. We should all do this preemptively. You're always going to want to change an API. It's going to break things. But this shouldn't be the first time you kind of put versions in. You should always have them there from the start. But the important thing here is providing migration paths between these different versions of APIs, right? So forcing a customer to migrate between API v1 and API v2 is terrible for retention. Because if a customer is like, oh, I've got to redo my whole integration, they take that as an opportunity to do a vendor review. They go and look again and say, well, actually, should I be using platform Y? Because I'm going to have to reintegrate anyway. Why don't I look at that? I strongly recommend replacing old APIs with shims to the new APIs. Very common concept. The way I look at it is, if it's 6 weeks of work for my team, why would I ask 1,000, 2,000, 3,000 customers to all do that 6 weeks of work as well? That just doesn't feel fair to the customers. You can totally use a carrot, which is new features, shiny new features, to tempt customers onto that new V2 API. That's totally fine. You don't have to backfit your new features into your V1, but offering this carrot to get onto the new API is a great way of helping customers grow. Yeah, don't just tell them, hey, you've got 6 weeks, 6 months, we're turning the old one off. That's not a great route to customer happiness or success. But be ready to get it wrong. I got this wrong a lot. I've written some horribly complex, over-engineered APIs that when I look back at them, I go, oh, why did I do that? That was a terrible decision. You want to iterate. You want to iterate with potential customers, current customers, with your own product organization. You want to learn and improve this whole process. It's important that you kind of try it and try it again, because it is always an iterative process, API design. So my summary would be, hey, there's couple of types of video API, encoding and platform. They've got more complex, maybe needlessly over the last 10 years. But a great API is critical if you're in a self-service SaaS environment where we're all going. And there's huge opportunity in targeting this developer market. It's an area of growth. We should be actively designing our APIs, but designing them for elegant abstraction, simplicity, ease of integration, and just that kind of right amount of stickiness in the product as well. And with that, I'm actually pretty much spot on time, which makes me very happy. If you have questions, corrections, please reach out. I can take some if we have time. I don't know how we're looking on time.
Thank you, Phil. Any questions? Comments? Yes, Rafael.
This clicker's really nice.
Thanks for an interesting talk. Given your experience with designing API, I want to ask you if you think there is a scope for standardization or some reference APIs for the industry, especially given the popularity of cloud computing and the availability of cloud computing also in the 5G network. So do you have any thoughts on that?
Yeah, I would love to see some kind of more standardization. I think the conversation came up yesterday around microservices and microservice API boundaries, and some conversation about some form of standardization starting to appear there. That would be super interesting. Generic interfaces to encoding vendors would be really interesting, but there's not necessarily an active encouragement for that, because obviously this kind of comes back to this stickiness concept. A slide that's not in this version of the talk, but is in another version, is the concept of having these transcode abstraction layers. This is something I built a couple of different places I've worked, but the idea is you have your own internal language for do me a transcode job, input, output, profile, that sort of thing. But underneath it, you can kind of pick, I want it to go to an elemental, I want it to go to FFmpeg, I want it to go to all these things. There's actually a good one, New York Times, I can't remember, I think it was New York Times put one out there. They have a generic abstraction layer over several transcoders, which is, I think, the direction the industry is going to go into, more these abstraction layers across different encoding vendors, for sure. Yeah.
Thank you.
Any other questions? Yes, there is one.
Inevitably at the far corner of the room. Keep going.
So if in the API I only include like the file path, there's got to be a lot of decision making, right? That you really have to do to understand what the GOP's going to be, what the bit rate's going to be. Can you kind of expand on how you kind of do mapping or decision making behind the API to kind of make the best decisions?
Yeah, sure. Without wanting to go too far kind of into a product pitch, we do a variety of things. We do a lot of machine learning. First thing we do is kind of look at the content and decide if it can be just in time, on the fly transcoded or not. If it can, we will pretty much just look at the content, figure out where the iframes are, figure out what the GOP interval is, and kind of make sure it's around the right bit rate to do a real-time encode on it. If that's the case, we kind of just chuck it into some storage and job done. we tend to do that only with a certain set of codecs, so H.264. You know, if you kind of put a ProRes in, we're going to have to transcode it down to H.264 first. The adaptive bitrate ladders are calculated based on some machine learning, looking at the content. So I'm happy to talk about this later, but we look at the content, categorize it, and make decisions on what the adaptive bitrate ladder should be best. So it's a per title approach, but based on machine learning. But that kind of runs in near real time as well. It kind of only adds 10, 20 seconds to the ingest. So we just scan through, pick out certain frames, run a categorization, and then throw that against an LSTM to generate an adaptive bitrate ladder. Yeah, that's pretty much how it works.
Okay, I guess we are out of time. Thank you very much, Phil.
Thank you.